Correlation. Correlation is how two things relate to each other. So correlation does have a notation attached to it. It's a little bitty R. There's your correlation. It's just a little R, okay? So what does correlation tell you?
How closely two things are to being related. Possibly.
Yeah, it's telling us how closely they are related to each other. And not only that, it's also telling us the direction of the relationship, okay? So correlation R tells strength and direction of the association of two, what kind of variables? Quantitative variables. Can I have a correlation for like hair color and anything else? No, we can't do that. Can't do that. Nope, can't do that. For two quantitative variables. Here's what R does not tell us. R does not assess how linear a relationship is. People will get an R value and immediately assume it's linear because of the fact that R is almost always used in a linear relationship, but you can get an R value even when something's not linear, and I'm going to show you guys some examples of that here in just a few minutes. Okay, so R tells us strength and direction of an association of two quantitative variables, but R does not assess how linear a relationship is. All right. Whoops, I think I skipped something. Nope, I sure did not. What are some characteristics of the correlation? So I'm going to show you guys basically how R is interpreted or where it falls. So -1 to +1. R is between -1 and +1, inclusive of -1 and +1. R cannot be bigger than 1. It cannot be less than -1. But it can be anything in between, including -1 and +1. So I'm going to draw a number line just because this is kind of helpful. So there's -1. There's +1. This is a super zoomed in number line. And there's 0 in the middle. So obviously, you guys, if we have a positive association, R should be positive, right? So if R is greater than 0, then we have a positive association. That's pretty, commonsensical, if you will. I don't know if that's a word, but whatever. If R is less than 0, what do you have? A negative association. Very good, very good, very good. That's pretty common. Most people can figure that out. Here's where it starts to get a little bit different than what maybe you're used to. So what does it mean if R equals 0? Okay, we've already talked about the direction, but what is the strength? What does it mean if R is 0?
Very weak.
Very weak association. In fact, it's probably so weak, it looks just like a bunch of dots scattered all over the graph with no kind of general direction. Like, it's just kind of like, wow, whatever. So R, the number for R is telling you how strong it is. The sign of R tells you the direction. Okay, so I'm just going to go on the positive side because everybody understands positive numbers better. So if I have an R value that is equal to 0.5, so a half. If my R value is 0.5, what do you guys think the strength would be?
Moderate.
That's moderate, okay? R equaling 0.5 or somewhere close to that, it's moderate. Now there's no there's no, if you tell me that 0.47 is moderate, I'm not going to tell you you're wrong. There's no hard and fast rule that has to be a certain thing. So it's just kind of ish, okay? Yes.
If I just say moderate, it can mean moderate, weak, or strong.
Yeah, you can actually say moderately weak. You can say moderately strong. You can say any of those. But generally speaking, once we get to about 0.8, that's kind of about where people start saying that it's a strong association. That's pretty much when we start thinking it's pretty strong. And when you start seeing pictures of correlations and their values, you'll start to kind of see why. And we're going to do a lot of that today. What if I have a correlation of exactly 1? Basically, here's what your scatter plot's going to look like. It's going to be like you could connect the dots with a line. They're going to be in a very strong linear pattern. Now, it doesn't mean that it's linear if I say that r equals 1, unless you can see the graph, but it's going to be pretty close to linear. Okay. So that's what happens as we go from 0 to positive 1. What do you guys think happens as we go from 0 to negative 1? Same thing, I'm just going in a negative direction at this point. So if r is negative 0.5, how strong is the correlation? It's moderate. Perfect. If r is negative 0.8, that would be strong. But it's just a negative and strong association. What's the graph going to look like if r equals negative 1?
It's going to look downward slope.
Yeah, we've got perfectly lined up dots that go negative. So, again, the sign tells you the direction. The value of r tells you the strength. Do you guys have any questions on that?
Pretty light.
Huh?
Pretty light. Light work.
Light work. Easy, right?
Light work. Like I'm playing
Perfect. So how do we get this R value? How do we actually calculate R? Well, I'm going to show you. Are you guys ready for the formula? I'm going to put it right here. Underneath is correlation resistant, because that's going to help us answer that question. Here's the formula for R. Super simple, quick little formula. 1 over n minus 1. So I take the number of data values and I subtract 1, so I have that fraction. Then I'm going to take the summation of x sub I minus x bar divided by s sub x. And then I'm going to multiply that by y sub I minus y bar divided by s sub y.
What's the bar mean? What's the xi?
Oh, let's talk about what these mean. What does x sub I mean?
Value of that.
That is a value of x for one of the data points, right? Because remember, each data point in a scatter plot has an x and a y coordinate, right?
Yeah.
So take the x value and subtract x bar. What does x bar stand for?
The mean.
The mean of all the x's. So I would have had to find the mean of all the x's. And I would take each x value and I would subtract the mean and divide by s sub x. What is s sub x? Standard deviation. So wait a second. You mean I'm taking an x value and subtracting a mean and dividing by standard deviation? You guys, this is the data value z-score for the x. This is the z-score for the x. Now, I would have to find the z-score for each individual x in the data set. So, like, if I have 27 dots, I got to find the z-score for each dot.
Why do I have to do that? She said so.
Then, what do you guys think's happening right here? I'm going to find the z-score for each individual y value. Then I find the z-score for each... For each y. So, you know, in a scatter plot, like each of these dots right here has an x and a y value. So I have to find the z-score for each x and each y.
There could be like 20 of them?
I know. Sometimes you have 10, 20, 30. I know, right? It's so fun. And then, you guys, what does it mean for these two parentheses to be next to each other?
Multiply.
I'm going to multiply the z-score for the x for that particular dot. I'm going to multiply it for the y z-score. I'm going to multiply them. Then, once I get the product, I will then sum all those products for all 20 or 30 or however many dots I got. Then I'm going to multiply by 1 over n minus 1.
Jeez.
Huh?
The number of,
What's n?
N is your number of values. So if I have 20 values, that's how many I would plug in for n. And so then I would do 1 over 19 and multiply it by the product of all of those things added up.
So you're just finding the average of the z.
I'm just finding the average of all the z-scores. Yes, I am. Absolutely.
like, what was y?
Wait, you said, and then you add it
Uh-huh.
to the r equals 1 over n.
So I add all the products together. Yeah. And then, yep. Mm-hmm. Doesn't that sound fun, you guys?
No, it's just
I ain't gonna
Ahem.
sound whack.
You will never, ever have to calculate R by hand.
Oh, I'm so glad.
Never.
Oh,
Never.
So what do I do?
So, here's what I do want you to think about, though. If this is the formula, which includes the x values, the mean of the x's, and the standard deviation of the x's, the y values, the y mean, the standard deviation of the y's, if it includes all of that, is correlation resistant? If I added a value to my graph that was far away from the rest of the data, would R change?
Yes.
A little or a lot?
Wait, if you change.
So I add another data value.
A little bit.
Okay, wait. Let's see if it's resistant.
It's a little bit.
So let's think about this. If I add a dot, another value, not only am I changing how many values I've got, that's one variable I'm changing.
You're also changing.
I'm including a new x. I'm changing the mean of the whole thing for x. I'm changing the standard deviation of the whole thing for x. I'm changing the y value. I'm changing the mean of y. I'm changing the mean of the standard deviation of y.
But it's only one value.
But it's only one dot changes every single value in that formula.
So it's not resistant.
It is not resistant at all. It is very sensitive to extreme values. R is very sensitive.
Because this is essentially like a giant mean, so like it makes sense that it's not resistant.
Absolutely. It is a giant mean with standard deviations, all of which that are not resistant. R is very sensitive to extreme value changes.
I want to say like
But
an
I think
example of that.
Yeah, thank you. Therefore, R is not resistant.
Wait, Miss Leakey.
I want to see like an example.
Hmm?
Miss Leakey, why is,
I'm going to show you an example.
Why are we saying extremely? Like, would anything be not resistant if it's extreme?
But like she's saying it's like super duper hammerhead or something.
Like it's
That little dot, is that extreme?
that one little dot's going to make a huge difference to my correlation. I'm going to show you a picture of that in just a second. All right, some additional facts about correlation. Because of the fact I'm taking each x and each y and I'm standardizing it, R, your correlation, has no units. Just like z-scores have no units, R has no units. They all cancel out. So R has no units. None. Zero. Zilch. If you see an R value given that has units, something is wrong. R has no units. Another thing about R is that R will not be affected by unit conversions in the data. That should make sense. If R standardizes everything and takes out the units, then whether I'm using inches or feet or centimeters or whatever, it doesn't matter because I'm taking all the units out. Does not matter. All right. Last thing about correlation that I want you guys to know. Correlation does not imply causation. What the heck does that mean?
Means that it doesn't necessarily mean because these things are correlated that they're causing each other.
Very good. Just because two things are correlated, even if they're strongly correlated, that doesn't mean that one is affecting the other or causing the other one to happen. I'm going to show you guys some really funny graphs here in a little bit. Maybe today, maybe first thing tomorrow, that you guys will be like, what? They have nothing to do with each other, but their correlation is super strong. So it's pretty fun. All right, I want to show you guys a couple of this cool little app thing, and then we will continue. Don't look. All right, so I'm going to put 2 points on this graph, and it's going to tell me the correlation. What's the correlation going to be when I put a dot here? Or I'm going to put the dot right here. What's the correlation going to be? 1. Positive 1. Why? Why is that 1?
There's only one line, and that's it.
That's right. I can connect those two straight line. Okay, I'm going to keep this at 1. Are you ready? Oh, man, that's the first time I've done it all day. Oh, man. So look, it does not take much to get the correlation a little bit off of 1. It's really hard to have a perfect correlation of 1 and negative 1.
Super not resistant.
Yeah, super not resistant. Yeah, super not resistant. So here's my data. All right, cool. Obviously, you guys can see it's a positive trend. You can see that it's a super strong correlation. They are very strongly correlated to each other. As one is going up, the other one is going up at a pretty consistent rate. All right, what is going to happen to the correlation if I put a data value right down here? It's going to go down a little bit or a lot?
A lot.
I want to see.
Bro, you put a dot way down there.
Way down here. What do you think?
Bro, that's a lot.
A whole lot?
I'm guessing point.
What do you guess it's going to be?
7.
I think
I'm going to put it right there where the mouse is.
0.6857.
Here it goes.
Actually, I'm counting 0.87.
685.
Bro, he's weak.
How not resistant is this? Like, this thing is super not resistant. So the closer I move the dot, the stronger it gets. The further I move it away, the weaker it gets. That one little dot creates a weak association. Just that one little dot. In fact, I can maybe get it to be negative. Oh, no, so close. I almost could. I almost got it there. Oh, well. All right, question. I'm going to put a dot right here. Right up here at the top.
That one's chilling.
Right there.
That one's chilling.
What will happen to the correlation?
It'll be very similar.
Stay the same?
Very similar.
The standard deviation of 0.2.
If you're still in like the general line-ish
Right here.
shape.
It's going to stay the same?
Similar.
9, 4.
Here we go.
Go down just a little bit.
Yeah.
Went up.
Why did it get stronger, you guys?
Because you're going higher the value, right?
So here's what just happened, you guys. Right now, the line of best fit, if you will, is only good right here. When I add a data value that's far away, it makes the linear relationship stronger because it's even more applicable far away. So that makes the association even better. All right, I want to show you guys a couple more things. Does the relationship have to be linear in order for it to have a correlation value?
No, I guess.
Looky there, I have a correlation. But is that a linear association? No, that is not linear at all, but it has a correlation. So be careful. Just because you have an R value does not mean you have linear. Okay, you have to look at the graph to see if it's linear. One other one that I'll show you that is not linear.
Wait, so making a circle makes it correlated?
I have correlation. So look, this is a sine wave that's kind of at an angle, obviously. But look, I've got a pretty strong correlation, but is that a linear model?
Why was the other one so low? But it was still like...
Because there was still some missing parts. It didn't make quite a line. Because every time I do this, it tries to create a line. So like I'm still trying to create a line, whether I have...
If that wasn't there, then one before would be strong though. Because that's the pattern to it, right?
Correct. So like this guy here.
Yeah, like that. It says it's weak, but is it actually like on a test?
So no, because look, the line's just it's trying to do its best to put a line there.
So is it always judged off of a linear?
Yep. R is always off of a linear, yes. Yep.
But even then, it's still the.
But just because I get an R value doesn't mean the graph is automatically linear.
Because if she finished that circle, then it's like
Correct.
super high.
I don't get it.
Not at that time, but like before when she was doing the circle, it was like 0.8.
Because all it's doing is it's trying to see how it's basically finding the standard or the mean of all the x's from this line and the mean of the y's from this line, and it's trying to find a correlation. How closely are they to a line? And like if I put dots here,
So if it's not a line, it's always weak.
yeah, can be. Okay, so there's correlation. So let's do a little bit of trying to see if you guys can guess some correlation values. So let's look at your notes again, and let's look at these two graphs. These are the top two. Look at the top on the left. First of all, decide, do you think it has positive or negative association?
Definitely negative. Definitely negative. 100%.
I was thinking negative.
If it's farther away.
So
it's closer
I will
to
tell you guys, if you ever have a situation where some people are saying positive, some are seeing negative, then that means it's probably pretty close to zero. Okay, because some of you are seeing it one way, some of you are seeing it the other way. So that means it's probably pretty close to zero. What do you guys think R is for this one?
Negative, positive.
I'm gonna say it's like a negative 0.002.
It is positive, technically speaking.
How? It's like there's more x's lower towards the farther away.
So it's because it's finding, somehow it's tilting a certain way positive, but it's all based on the formula. This is positive 0.05. So yeah, it's positive, but it's barely positive, y'all. So like those of you who are seeing a negative, I can see I personally see the negative in this.
Wait, hold on. Is it? I thought it was just. Is it where the bulk of the dots are?
It's how close they fit, like to each other. How strong are they correlated to each other? You as we practice, you'll see it more. Try this top right. What do you guys see? Do you guys see positive or negative?
Negative.
Does everybody see the negative here?
Got it.
Okay, so this is definitely negative. And then what R value do you think this one has?
0.08. 0.0.
How do you get the?
How do you know that?
Huh?
I'm joking.
You don't see the negative, so
It's probably 0.05.
do you see how it's kind of trending negative like that?
0.0.
That's what we're talking about.
But the other one.
0.0.
Yeah, I agree that this other one also seems to trend negative. I agree with you, but there has to be something. It's probably this dot that is causing it to flip to the negative. Just like I almost got that other one to flip negative, even though it looked very positive.
If you look at like the bulk in the middle, it's trending upwards.
Yeah, so like if you look at the bulk of this data right here, yes, that's trending upward. So that's probably why it's positive. Yeah. So, what do you guys think over there?
0.06.
This is 0.25. That's 0.25. Now, again, that's still very weak. Okay, we're not to we're like a quarter of the way to moderate. All right, let's try some more. The next two, left one. What do you guys think? Is it positive or negative? Obviously, it's positive. What do you guys think this value is?
I don't know.
How do I know the numbers? Because I got it out of the textbook. And the textbook told me. Yes, totally. Yeah.
0.05 on the first one.
No, you'll see. All right, what do you guys think? About what is this? This is 0.5. All right, what about the one on the right?
That's like negative.
Totally negative. Absolutely. 100% negative. What do you think?
0.6. 0.6.
0.7. All right, you guys, bottom left. What do you think?
That's a strong upward
Well, that's like.
Who said 0.85? Let's go. All right. Bottom right.
Negative 9.
This is negative 0.9. 8. Very good. Very good. All right, we're going to do some more practice with that in just a minute. But let's look at what is this going to look like on like a homework assignment or a quiz or I don't know, like a concept check or something. So like, let's look.
This is a question.
The following scatter plot shows the height in inches and number of steps needed for a random sample of 36 students to walk the length of the school hallway. The correlation is R equals negative 0.632. Explain why it is not correct to say that the correlation is negative 0.632 inches per steps per inch. Blah.
Because there's no units with
Danny. Yes. R does not have units.
R don't have no use.
That's right. There should not be units there. If those units were not there, then this would be correct. But
So you just say negative 6.
the correlation is negative 0.632.
You said point.
I can say a decimal.
You said you want.
Negative 0.632.
I thought you just said. What does it mean by units?
Units, meaning steps per inch. Ah! All right.
Oh, I get this.
B. Guys, what would happen to the correlation if the number of steps was accidentally used as the explanatory variable and the height was accidentally used as the response variable? Danny.
the positive and negative.
Positive and negative would flop?
Yeah.
So would R become positive now?
Positive, yes.
Yeah, right? Wouldn't it?
No.
Wait, no, because it's
I
still
feel
the
like
same
you
amount
got
of
to
correlation either way, right? Because it's not like one's more correlated when you flip it. It would just be, it'd be, like,
Yeah, but it's
it would be like pretty similar, right? Because correlations always. So think about it, it's not like an addition problem, like they, I mean not addition, I mean like a subtraction.
I have a question for you guys.
Oh, but this would have to be.
What is 2 times 4?
Hey,
What is 4 times 2?
hey,
What is negative 2 times 4?
negative A.
What is 4 times negative 2?
Negative A. I'm an
What would happen if I switched my x's and my y's?
Let's go.
Wait, hold on. What did you just do there? You like did the whole like.
Because these are being multiplied.
But why?
Because the formula says
Wait,
to
what-
take
oh,
this
what
z-score and multiply by that
I
z-score.
got it. What numbers are you?
It's not subtraction or
Is it like negative 2 times 6?
Yeah, so negative 2 times 4. What's negative 2 times 4?
Negative 8. Where did we do that?
That's negative 8. What is 4 times negative 2?
Negative 8.
Still negative 8. So whatever order they go in, whether I put the x's first or the x's second,
Order, that's what it's for.
correct. So it doesn't matter if I put the x's first or the y's first. R is not affected. Now, guys, I have really good news for you and really bad news for you.
Bad news first.
The bad news is that if you switch the x and y, you're going to miss everything else about the problem. Do you want the good news? You'll at least get R right.
Yes.
All right. What would happen if the correlation in height was measured in centimeters instead of inches?
It wouldn't matter because
R is not affected by unit changes.
Are we gonna get a lot of questions like that where we can just say it's not effective?
Heck yeah, man!
Like on
I love R. R is great.
No, but I'm saying like, are they gonna do like these stupid questions? Where it's like,
Probably.
and then they don't switch
You're not
with
stupid.
it.
that's a
Pretty
free.
smart.
All right, let's look at this last question, last couple of questions here. Interpret R. You guys know what it means when you say the word interpret, yes?
Means we gotta do all.
It means write a sentence. All right, what does R equal, by the way?
Equal to
Negative. Oh, I can't.
Okay, cool. Here's how we interpret R. There is a, all right, first we're going to say direction. What direction is it? Negative.
moderate.
And what's the strength?
Moderate.
Moderate. There is a negative moderate association between,
Height and number of steps.
perfect, height and steps per inch. There you go. That's my interpretation of R. I literally just said what R stands for.
So it's just the stuff from the
Huh?
question.
No.
Steps per inch, isn't that what it was?
It's
I thought there wasn't any.
It would be-
So, okay, that's a really great question. Cole says, wait, why are we putting units in there when there's no units? I am telling people that there is a negative moderate association between the two variables. The variables here were height and steps per inch.
So we don't. So you don't actually put like the R value in.
Correct. Correct.
And then can we,
Perfect.
Can we for this one? Can we be like logically this is causation or whatever?
Maybe. Yes. Yes. But no, there's never causation. Correlation does not imply causation.
Your two variables are the number of steps someone takes.
Oh, my bad. My bad. Okay.
What is the number of
Height and number of steps.
I don't think it's that.
It's saying
That's what I put.
You know,
from
it's definitely.
how many steps are you taking if you're going a certain distance?
Yeah, no steps.
Okay. Well, it's the variables. It's the variables.
Because it doesn't tell you the distance.
All right.
Well, she changed it. Number of steps.
Number of steps, is that it? It's just number of steps. Okay, perfect. All right. All right, you guys, so that's our example. Now, I just want to make sure I'm very clear here. We are done with that problem. This is a brand new example. Are you ready? Here's the question. I want you to think about it. Which association is more linear? An association that has an R value of 0.5 or an association that has an R value of 0.9?
No, because it doesn't matter because it's not
It
linear.
doesn't tell us. You don't see the guys in the If I were to guess, I'd say 0.9, but like.
R value doesn't tell how linear it is.
Yeah, it doesn't tell you it's linear.
I don't know. I think y'all are.
Final answer. No, that's my final answer because we.
Stop with that.
Yep.
Oh, that's
Yep, yep, yep.
Trick Westy.
Easy.
R does not tell how linear an association is.
I'm like actually so smart.
Huh?
Can you show us examples where like where that is? Like
Mhm.
you know, what you want?